Hello and welcome back to the course. In this lecture, we're going to talk about the rise of deep learning. So why has deep learning become so popular? Now, before we start, actually neural networks were around in the 90s. Okay, so LSTMs, for example, were developed in 1997, and CNNs, convolutional networks, were developed in 1998. So they were around a pretty long time ago. However, deep learning only became popular in 2012. So this is the paper that proposed convolutional neural networks. It's called Gradient-Based Learning Applied to Document Recognition. As you can see, the date is 1998. And this is the paper that proposed long short-term memory, or LSTMs for short. And as you can see, it was published 1 year before CNN, so it's in 1997. So they were around a very long time ago. However, they only became popular and people started to use them in 2012. Why did that happen? Now, there's 3 reasons why this happened, so let's go through each and every one of them. Now, one reason is the availability of datasets. So, for example, datasets which includes a million and thousand of images, such as ImageNet, for example. ImageNet is a dataset or database of more than 1 million images of 1,000 different classes. So, when these datasets became available, then deep learning would obviously work, because deep learning is meant to work for big datasets. So of course it can't work for small datasets. You're going to need a lot of data in order for deep learning to work. So the availability of datasets is one reason why deep learning has become so popular. And of course now you have a lot of datasets. So nearly every year there's a new dataset coming out. Okay, so this is one reason. But the second reason, which is in fact the most important reason, is the availability of computational resources, such as graphical processing units, GPUs. Okay, so usually training is done on GPUs, because if you train it on CPUs, it would take forever. Okay, if your network is large and you have a lot of data. So CPU wouldn't be enough, of course. It would take forever. It would take days, depending on the CPU that you have. However, if you're using a GPU, it would take hours or maybe less than that. Okay, minutes, depending on your architecture. So for example, object detection, if you train an object detection network on NVIDIA GPUs, then basically one epoch would take around 12 minutes, according to one project I saw recently. However, of course, if you train it on a CPU, it would take days. So the availability of computational resources made it possible to train deep neural networks. And the third reason, which is related to the second reason, is the ability to deploy matrix multiplication to perform on GPUs. So previously GPUs were available for other purposes, such as computer graphics. But then when researchers could deploy matrix multiplication on GPUs, then of course this speeded up the training, because at the end the neural network is just a bunch of matrix multiplications together. You're multiplying the input with the weight, getting an output, multiplying this output with another matrix of weights, getting another output, then multiplying this third output with a matrix of weights, and so on. So at the end it's just a bunch of matrix multiplication. So when you can perform this matrix multiplications on a GPU, then definitely this is the main reason why training can speed up. Okay, so this is the third reason why deep learning has become so popular. And now specific libraries from NVIDIA, for example, CUDA-NN or CUDNN, is a GPU accelerated library of deep neural networks. So it provides highly tuned implementations for standard routines, such as forward propagation, backward propagation, convolutional networks, pooling, and so on. Okay, so here you can see the performance on recurrent neural networks, and here you can see the performance on convolutional neural networks. So who pulled the trigger? Who is the one who started deploying deep learning on GPUs? And it was a paper from researchers at the University of Toronto. Okay, so this paper is called ImageNet Classification with Deep Convolutional Neural Networks. Okay, so previously people were using support vector machines, which is a machine learning classifier to classify images, especially the ImageNet database. So this paper was the first paper to use convolutional networks to classify images. And why that happened is because they used GPUs. They could deploy matrix multiplication on GPUs, so this immensely speeded up the training. And as you can see, they divided their network into two parts. They ran it in parallel on two separate GPUs. So the first GPU runs the first part of the network, and the second one runs the second part of the network. So for example, the last layer has 4096 neurons. Okay, so they split it up into 2048 for the first GPU and 2048 for the second GPU. Okay, so this immensely speeded up the training, and they could successfully achieve the best results, much more better than support vector machines, and they won the ImageNet classification competition. Okay, so this is considered to be the World Cup of computer vision. Whoever gets the best result each year then wins. He wins the competition. So this is how it started. This is the story of how deep learning started. It started all in 2012. So that's it for this lecture. Thank you very much, and I'll see you next time.